Today, I just want to cover what I would consider to be maybe the major concerns. When I was asked to give this talk, I kind of reached out and bounced some ideas off of people. What are the things that really seem to come up? Energy and protein intake, of course, tops the list. We want to talk sometimes about pregnancy toxemia, milk fever, mineral requirements. I'm by no means the mineral expert, but I'll give you my opinion. Water intake usually comes up in casual conversation, and colostrum quality. Well, I'll just do a little breaker there for you at the end. I'm not going to talk much about colostrum. From what I can tell still, the biggest thing that faces us within the sheep industry is making sure those animals get it, making sure those animals get it early. And we have to get it early because the barrier function really kicks in and blocks the absorption of immunoglobulins after 24 hours. And I think right now we could just focus on getting lambs to colostrum within that first 12 hours. We'd be making massive progress. As far as nutrition and impacting your quality of colostrum, it's just not there yet. And the dairy folks will figure it out for us. Trust me. When I think about nutrition and actually balancing diets, I know one of the things you're probably looking for me to do today is to give you a requirement, tell you it's got to be 16% crude protein, or tell you that you got to eat this many pounds of a certain feed. And the truth of the matter is, this is the diet that I threw together, and I can write any diet you'd like and make it work. Okay? So if I pull this diet today, tell you I'm feeding it to some pregnant ewes that are going to give birth here in about 2 weeks, there's a couple things that should stand out to you. The crude protein is under 12% on a dry matter basis. Red flag, right? It's pretty low. No, it's really not. Because what I've done is I've looked at what my crude protein in pounds intake is going to be delivered, and the volume of intake more than covers what I need. From a copper standpoint, I'm over the ppm. And truth be told, they're just fine, right? Now, do we have data that says that we need to be careful about copper, especially sustained over time? Of course we do. We have plenty of data to support that. But that's also operating under the assumption of standard absorption, and much of the copper in this diet is bound up in a lot of my feed stuff. So I know that I have some safety measures in place. And so what I really want you to know is that a lot of balancing a diet is an art. So I'm not going to give you a go-to number and tell you that that's what you need to live and die by, because that would be poorer advice than trying to get you to think about what I consider to be vitamin M. So this is the picture I always use. These cows, great diet, but if it's not pushed up, how are they supposed to eat it? Are they supposed to make milk? We make the same mistakes many times with our sheep ration. So ration is what we think we've drawn up on paper, right? We've got a nice diet, but then we've got to actually get it mixed at the farm or at the mill, get it home. It's never perfect. I'm happy sometimes if it just doesn't get rained on. And then I got to deliver that, actually weigh it out. How many people are weighing their animals or body taping them, deciding how big they are? How many people weigh their feed or weigh the scoop every so often to make sure that it's about right? Are we delivering our grain and our hay separate? Right? There's a lot of different confounding influences here. And so it leads the nutrition side of things to be a little bit more of an art and take a little bit more interpretation. So what I'd like to cover today maybe are some of the fundamentals that might influence the decisions that you'll make back on your own home place. So just a basic ruminant nutrition review, we have those different compartments to the stomach, right? The rumen is that fermentation vat. We have to keep the microbes happy. They grow us the B vitamins, they grow us the protein, a good majority of the protein for sheep. We favor them by keeping the pH stable. That's a management thing. It's consistent daily feeding, consistent feeds, no dramatic changes, plenty of fiber for fermentation. The reticulum is our particle sorter. The omasum is our water filter. The abomasum does that final acidification. And then the small intestine is where we hopefully get those nutrients absorbed. And we've got a lot of different nutrient categories to work with. And this is why it becomes an art, because I can balance a diet and provide energy from multiple sources. I have a lot of different micro and macro minerals to take into consideration, the interplay of fat-soluble vitamins, how much structural carbs are going to come from forage versus roughage, whether or not those animals are out on pasture, whether or not I have adequate sources of grain, let alone the influences of toxins and the pressure that we have from that standpoint this year. The end goal is to keep those microbes happy. So, we've got them swimming around here. They're busy. They're happy. My guidelines there when we think about dairy cattle, and that's where I was trained, we need to keep that fermentable starch probably above 20-25%. And I think that's not a bad number to consider in sheep as well if you're trying to provide enough energy for them to grow and generate that protein. You have to keep the forage fiber above 10%, in my opinion. And that's going to stabilize because your fiber digesting bacteria will help balance the pH. And you need enough of them to be able to survive in there and balance that out. You have a lot of different fibers, different types. They degrade at different rates. And sheep make this even more complicated because to grade fibers, we need to get them all chewed up, right? So as we're going and chewing through those fiber and we get all these puncture points in that waxy outer layer and we increase all this surface area for exposure to bacterial enzymes, what stands out is actually a pretty big difference between sheep and goats versus cattle. And so what we know about cattle is that they're pretty good at filling the rumen up and consuming a large amount, finding a place, ruminating efficiently and getting that ground up. Sheep do a lot more chewing. For every single gram of fiber that they're going to eat, or every kilogram of fiber, they do a lot more chewing, but they chew it to be finer. Okay, so we need to take that knowledge and apply it to what we know about the fibers that we're providing them. So sheep are going to thrive better on our average quality hays, whereas our cattle are going to do better on our poor quality hays. So you have to be careful that you don't put sheep out and expect them to make good use of a really bad batch of hay. It might be the bolus size, it might be just their general behavior. But what we know is that sheep won't move through the same amount of fiber in a day as a cow will, scaled to their body weight. So that load on the far right there, that's grams of fiber per kilogram of body weight. And sheep, they just don't move as much through. Okay? How do we capture that when we think about feeds? Well, with the climate shifting, and I've talked about this before, there's pressure that we need to start thinking about other sources for fiber besides hays. Soy hulls are a good option. Cottonseed is a standby as well, although it's a bit pricier. So then we have to start thinking about the combination of what's available in the marketplace, what's the amount of fiber or the amount of NDF, and then how digestible is that? And when we actually try and scale that and apply it back to price, and we'll see some things start to trend out. And we have to think about, why are we feeding the fiber? So remember, I said there's a kind of a minimum you must have of forage NDF, but then you can sub in some more fiber from a different source. And when you think about the pregnant ewe and you know that she's running out of space, putting in something that she doesn't have to spend as much time chewing, putting in something that doesn't have to reside as long for her to get energy from it. A soy hull, for example, that's finer ground and processed, but still providing that fiber. It's going to move through quicker. It's pretty digestible. It might be a good replacement for those ewes that are filling up and struggling to move enough through in a day to get that energy. So what we know is that as we feed more soy hulls in replacement of hay, we have an interplay over here on the right where 1/3, 2/3 soy hulls, we get actually better total fiber digestibility in the diet. And it's not until we're fully on soy hulls that maybe we're losing a bit. Certainly, we're still doing better than that hay in the control treatment. The animals are eating more feed as well. And that does associate with a slightly more expensive feed bill. But when you get into that late gestation where they're filling up, this is an opportunity to push a little bit of fiber through in your diet. And it's something that's pretty easy to manage in your feed bin, rather than trying to find a rapidly digestible or a really digestible hay, because they might be in pretty short supply. I know there's some other people who will speak to you more on soy hulls and their application within feedlot animals, and I'm personally excited to hear more about that as well, because I think it's a great opportunity. So we turned out a paper maybe this fall thinking about the energy or protein requirements for gestation. And it's probably not my most popular opinion when I tell you that no matter how hungry the pregnant mammal says that they are in the first 2 trimesters, she really doesn't have that big of a demand for her protein or for her energy, right? This is our metabolizable energy that's required for pregnancy. And you can see a dramatic increase in that third trimester. That's what should really stand out. And it's a dramatic increase only in the third trimester, not before that, not before that. That same increase is matched to your metabolizable protein. So why are we always talking about your energy instead of talking about your protein supplementation, right? I told you at the beginning, I can get away with feeding a 12% crude protein diet, but I pay pretty close attention to that energy in my diet. Why am I so honed in on the energy instead of the protein? Well, when I run the math and I pull, an average 2.25 hundredweight U in that final month, and start looking at, let's just look at all 5 months. So in the first month on just hay alone, she's going to be in excess for energy, just average hay. Same with the second month, even the third month. She might even break even if she can really pound that hay through, and it's pretty good hay and she can get a lot of it. She might even break even in the fourth month, right? This is a twin bearing, 2 12-pound twins at 2.25. What you're going to find is when she breaks into the beginning even of that last month, she's going to be at a deficit. A deficit that is increasing so dramatically that you can't meet it with 1 pound of corn supplemented. And I've calculated where that pound of corn is exchanging out the hay. You can't meet it if you supplement 3 pounds of corn. And by the time she's ready to give birth, you're going to have some trouble getting enough energy in her by over a 50% substitution of hay for corn. And corn is really our energy standard in this case. On the flip side, if you think about the amount of protein coming from not just the corn, but the hay, the diet alone is going to provide up to a 1/2 pound of crude protein on a metabolizable basis. And she's going to require less than that. So even as you're scaling up her requirement for protein, she's probably been over the whole time. So unless you've really dialed back the protein in your rations, there's a good chance it's not going to be your concern. Energy is. So to pay attention to energy, the first thing you got to do is make sure that you've estimated the body weight correctly. Most of us guess wrong. I guess wrong. Take a tape, we'll buy it at Joann's or Amazon or wherever else, $5. And it's within 5%. It's pretty good. Usually about 2% unless it's an odd-shaped sheep. Measure around the heart girth, multiply that out, get a rough estimate of body weight, and that tells you how much they should be eating. Think about 2.5% of their body weight on a daily basis. The biggest thing then is to go and body condition score them. So actually go and score the spinal process, evaluate how much flesh and or fat is covering that, and shoot for a 3. But by the time she's pregnant, it's too late to change it. This is something you need to be managing through the summer. When you go and check on them, you're moving them through, you're worming them, you're trimming hooves, you're shearing them. Those are your times to feel them. Keep a note, pick out the same ones every time. You don't need to score the whole group. Take some lows, take some highs, score them, and then check them in a few more weeks or a month. When we get into the winter, especially this year is a great example. So I got this fake background behind me with these happy snowy sheep, right? This is a great example this year where you need to think about increasing the amount of energy you give them or just flat out the amount of feed you give them by at least 5% for the cold weather. Now, they're in fleece, they're staying pretty warm, I understand that. But you'll notice they'll really pick up and start making noise as they get hungry. And in this case, it's not just a pregnancy brain hunger. They're legitimately hungry and cold. More if they're muddy or if it's really hot, if you're doing this through the summer. And when it gets very cold, I know we're looking at some single digits here, up to 20% more. That's at least what we'll do here. This Farm Health Online has a nice body condition score chart that'll guide you right through it if you haven't done it. Like I said, it's too late to change it by the time they're pregnant. And so we have this opinion that we can pull back the energy and really dial in the size of the animal, or if we really push the energy, we can overgrow those and cause some issues. Neither one has been a big issue in my experience, but I will tell you, you're more likely to overfeed and cause big lambs than you are to underfeed and cause small lambs. Undernutrition it's not going to get lamb size down for you. It might give you some weak lambs or weak ewes, dead lambs, dead ewes. That's certainly not your goal. So if you take a large data set like they did with these, I think they're Irish black-faced sheep, Welsh. They're Welsh sheep. It's a nice big data set, but all it really ends up telling you is big sheep eat more food. Well, we know that. Bigger sheep have bigger lambs. We know that too. And if sheep are going to have twins or triplets, then each one of those lambs will be smaller than total fetal weight is greater, but each lamb is smaller than that single would have been. So the biggest thing you can do for yourself is get yourself to twin. That all starts again back in the summer, managing your body condition score, going into your early breeding season, having a successful flush, and choosing animals with genetics or a propensity for multiples. And that's your best shot at reducing your dystocia. Okay. So high intake could increase your lamb size a little bit. Undernutrition, certainly not going to help. Don't underfeed them, it's too late. From a metabolic standpoint, I want to touch on a couple. Pregnancy toxemia is the big one. What happens? We have those fat animals, or even some average body condition or light body condition score animals. As the fetus continues to grow, or multiples, they press up on the rumen. This is a bigger issue the more conceptus volume is being occupied. And so your twins, triplets are going to be at a greater risk here. They're pressing up on the rumen and they're reducing how much space she has left to push food in. And the ewe is requiring her liver to take fermented energy, so VFA from the bacteria, and build glucose with it. She survives on glucose. So we would say that her liver is gluconeogenic. What ends up happening is that the liver continues to try and push out glucose, but because she can't get enough VFA from her fermentation, then she starts to pull her own body fat to try and build and circulate energy from her body fat. And as a short-term strategy, this is great. It's fine. We do it in dairy cattle all the time. But as a long-term strategy, she starts to build up some ketone bodies that are going to be toxic, and she starts to have some accumulation of damage in her liver. And in dairy cows, we would see this post-parturition where they've calved in and they go off a feed and they're displaced. And we have a lot of struggle getting them full again and up and running. In this case, we're also having trouble getting the ewe full, but it's because there's no space before she lambs. It's usually going to be pre-lambing. So your biggest thing is to prevent it, keep your energy up. Keep your energy up with fermentable carbs. Don't just dump a bunch of fat in there. Once it's already onset and you see that she's really lagging and dragging, you've got to jumpstart that liver. So you're going to put in like a propylene glycol, which is a precursor for glucose to help that liver signal in the right direction, because otherwise the fat mobilization triggers to her brain and says, well, we're moving fat, so it's all good. And it actually can suppress her appetite. So she's moving fat because she's hungry, but then she's getting told by her brain not to eat. And so she's going to downward spiral in a hurry. Ringworm. So this is different from that first time ewe that really struggles to dilate. And what you'll see in a couple of papers, and there's not a lot out there, but that does seem to associate with low serum calcium. Personal observations from some diets I've seen here in Ohio in the last couple of years is that many diets rely on just one source of calcium. That's fine, but are you testing the bioavailability of your calcium? Do you know that it's actually available, or are you just dumping in the source that you can find? And if you're not 100% sure, you might be better off to hedge your bets and put in a couple of sources. So if one of them's not that good, at least you got two cards at play, right? Many diets on paper that I see right now, they're only meeting a calcium requirement maybe 1-to-1 with phosphorus. And this is not just a bone growth risk issue for lambs or for ewes, but it's going to limit her free calcium availability. It's also going to lead to some hypocalcemia down the road, which is our next topic. So the biggest thing you can do for yourself here is keep track of your calcium. And at least for now, all indicators are otherwise that this is a genetic issue that needs to be called out. Hypocalcemia then is where after she goes to lactate and she tries to mobilize that calcium from her bone, she doesn't do it very well. And we see this challenge. We think it's difficult in sheep. Go try and deal with hypocalcemia and bone calcium resorption in a dairy cow, where she's really working pretty hard to push out 50, 60 pounds of milk in that first month. So we have, in this case, Again, many diets that are pushing calcium to phosphorus either a little bit low, or I've seen diets up to a 4-to-1 in the last year. 4-to-1 calcium to phosphorus is going to cause the opposite problem with the same result. Bone growth issues, really high blood calcium that's going to be modulated, and many of the signaling pathways are going to be down-regulated because there's so much calcium the body doesn't have to work that hard to find it. Because it's everywhere, and when she finally needs it, and she pulls it out of her blood, her body's not prepared to mobilize the next level from the bone. So vitamin D deficiency can inhibit and negatively play into this as well. Ways we usually counteract this, traditionally, we would think about boosting the calcium status with alfalfa hay. If alfalfa hay is hard to find, buy alfalfa pellets. Mix those right in with your feed 50-50. And buy a bag or two of those, and that's what I like to do to just get the use started in the first couple of weeks. And by that point, you don't need that alfalfa hay anymore. It's pretty expensive, best to let somebody else pay for it. You just need a little bit to tide you through for the first couple of weeks. Pellets will work. From a mineral standpoint, I don't think I'm allowed to give a nutrition talk without talking about selenium. Historically, and this is an updated map, but it's the same old thing, and there's a nice summary there at the University of Georgia. Historically, this was a health issue because the soil is deficient. Okay? And within Ohio, Michigan, Indiana, is the soil still deficient in selenium? Yeah, it probably is. How are we going to know if our sheep are deficient? Well, sometimes it might be a little too late. You're going to have those weak lambs, poor doing lambs, and they might die. You're going to have in your growing or adult animals more muscle fatigue, stiffness. They're going to be kind of hunched over. And my personal take is at this point, the BOSI injection is difficult to get a hold of at times because I think there's some illicit uses for it in other parts of the human population. But also, we add plenty of selenium into the diet, most diets. You need to look at your free choice mineral, because your free choice mineral, there's a good chance it's actually already providing selenium. And if you're putting selenium in there and maybe you're mixing some selenium in a premix within your ration, or you've got a supplement pellet, you're probably already providing plenty of selenium, and you just may not realize it. Now, if you're doing all of your diet formulation from corn and hay, you don't use a free choice mineral, then you might be running into an issue. Somehow you got to get that selenium in there. I'm doing it through a free choice mineral. What I want to talk about here is, let's look at these two minerals for a second and just ask yourself, how do these differ? Okay, the tags are a little different, sure. Might be difficult to sort out on the guaranteed analysis how these two actually differ. What if we go and pull the ingredients? Pull the ingredients for the one on the left. Something's going to stand out that doesn't appear in the one on the right's ingredients. That's going to be these amino acid complexes. Okay, so we have different types of mineral sources that are out there. Amino acid complexes would be what we would call an organic source. These oxides that are down here in the mix, those are an example of an inorganic source. And we also have some hydroxychloride minerals as well. Not all minerals are created equal, and there are taste differences in minerals, not just the salt that influences intake, but the taste as well of the minerals and the way that they interact. Oxides are not going to be as available. They're going to be cheaper, sure, so you can put more of them in, but are you? That's the question you have to ask yourself. And if you're not going to, and you're only going to put a limited amount in, make sure you put in something that's a little bit more bioavailable. So an organic complex would certainly help. Even some of your sulfates are going to be improvements on your oxides. You need to pay attention to the quality of mineral that you're getting, and that you're not just dumping it out there and counting on it to do the work for you. Certainly wind and rain exposure, it's not just loss, but it's damage to the palatability of the mineral mix, as well as the availability of that mineral mix when it gets down into the small intestine. And it may not even make it there because it may interact within the rumen before it gets there, right? There's a lot of different pieces at play, but your mineral mixes are certainly not all created equal. You need to consider how you're providing it and what your expected intake is. From a water intake standpoint, man, there's nothing like fresh water day. clean the tank out, and I don't clean it out a lot, but I clean it out, once a week. It's pretty good. Fresh water intake is a pretty big driver. So can I numerically tell you that if they don't drink a certain amount of water, they're going to struggle with lambing? Now, every time we've tried to do those studies, it's really difficult to tease it out. What we find is that in the interim, sheep do a pretty good job of balancing out, like most ruminants, when they're full, when they're empty. How do they make up for that difference? But we're going to expect they're going to drink at least a gallon of water a day if it's available. Otherwise, they might try and scoop it from snow. And if that's not available and they're not getting it from their feed, then they're going to have to borrow some water. And when they go to borrow that water, they borrow it from the rumen and they borrow it from the fetal sac. And I don't know a lot about what happens when you borrow the water from the fetal sac, but it just doesn't sound like a good idea. Keep the water thawed out, provide them the water available whenever they would like, clean, free of any off odors as best as you can, or bird or cat contaminants, and you'll be in a much better place. When we think about transitioning from our ewes to our lambs, my one little stool I like to get on every single time I can is to talk about getting them on creep feed. So this lamb in the middle, it's my favorite one to talk about. That's about 2 hours old. It's got its head stuck in the feeder. Yeah, it was a giant. I get it. Okay? And did it really eat substantial amount that day? No, but I can tell you that was a heck of a lamb by the time it was done from a feed efficiency and growth and productivity standpoint. It probably had some really great looking rumen papillae. So all these little finger-like projections on the right here, these are from calves, but this is the reticulum, that particle sorter, and this is the rumen wall, and all those little things there, those are responsible for absorbing the VFA and sending them to the liver so the liver can do the work. Over here, the milk and hay calf, look how smooth that is. So the old idea of getting them started on hay first, you got to get them started on some creep feed. They can have some hay, they can nibble on it, that's not bad for them, but the goal needs to be to get them on creep feed as soon as possible to develop that rumen function. You can have them on feed on their own and do some early weaning when situations require, if you get them started and you expose them with fresh feed every day, something that's available to them. We talk a lot about requirements. I know some of you probably hoped I was going to give you exact requirement numbers for these animals. But all you really have to do is you can balance your hay and your corn and probably make most things work. I have started to really shift my focus to think about responses. So requirement is what is needed to survive, to achieve function. But sometimes we give above the requirement. We get an additional response within reason. Some examples. I'm meeting my crude protein requirement for my sheep, but I give them additional lysine and I increase my muscle accretion. I'm meeting their requirement, but I give them additional methionine and I get some improved wool fiber quality or length. Methionine can also help prevent mastitis, lower somatic cell count in dairy cattle. There's some evidence that it improves fertility by early, first trimester survival and viability of the fetal attachment. Zinc, we know, can really improve and increase foot health. Vitamins can impact immunity positively. But the one I don't think very many people are paying attention to is the epigenetics side. And I think this is one of the only pictures that's not mine, and I can't frankly tell you where it came from, but those are some nice Scottish black-faced sheep up there. You can thank Google for that. What they did in this study a few years ago is they took a group of sheep and they fed them either a folic acid, that's your B9 with methionine and B12 deficient diets, or they added those in the diets. And at the first year, everything looked normal. Lambs come out, can't tell a difference between the groups. But by the second year, about 2 years old, they pulled those ewes and they pulled those rams, and there was a 4% shift in the DNA expression of the ones that were fed the deficient or the above adequate diets. And there was also an effect across genders. So males and females responded to this supplementation differently, which is fascinating. What we noticed in this paper, I say we, I didn't have a chance to directly participate in it, but I'm an avid reader of the work. The males were much fatter and insulin resistant. And what it does is it signals how the way that you feed the ewes today will influence the genetics and the genetic expression of your sheep a year or 2 years from now. So some of the decisions that you make that you know are right, I would just encourage you to stick with those, even if it doesn't seem like it's quite worked out for you in the first year or you've noticed a difference. Give it a chance. Maybe boost your protein a little bit if that's what you're after. Make sure your energy is not deficient. Drive that water intake. Seek a higher quality protein supplement instead of chasing a higher crude protein. Chase a higher quality supplement, or change your mineral bioavailability out and upgrade your mineral. And give those decisions time to play out, and you might find that investment was worth more than you realized. So again, it was a pleasure to have you today. I wish that we'll have a chance to do this in person in the future. And I wish you all a great rest of your day and your week.